Good morning, Monday morning. I just woke up, so forgive me. I'm a little slow on this. Okay, so today I wanted to go over going from permutations, where permutations order is important. The way you put first, second, and third place, or if you're putting things in a line. Um, Now we're going to go into combinations. And combinations are just grouping things, putting people into a committee. Doesn't matter if you're selected first or last, you're on the committee. Selecting people for a team, putting things into groups. And this part really goes into what our whole next unit is about with sets. Because when we start talking about sets, order is not important. So your first example, it's there's six seniors in a club, and Adam, Betty, Carl, Donna, Evelyn, and Frank. Um, I did that on purpose so that we can just call them A, B, C, D, E, and F, and not write out their whole first name. So, how many ways can two of them be selected on a planning committee? Well, if you think about this as just listing out all the possibilities, you could do Adam with Betty, or Adam with Carl, Adam with Donna, Adam with Evelyn, or Adam with Frank. But then when you start your next list with Betty, well, you've already had Betty and Adam together. There's no need, or it'd be redundant to list that because it'd be the same pair. So you go from, and you can't list BB because you can't repeat. This is an dependent situation. So Betty then would go with Carl. Betty with Donna, Betty with Evelyn, and Betty with Frank. And then Carl. So Carl, he's already been with Adam. Carl's already been with Betty. Carl with Carl wouldn't exist. So Carl with Donna, Carl, Evelyn, Carl, Frank, and then Donna with Evelyn, Donna with Frank, and then Evelyn and Frank, and no need for Frank because he's already been paired with everybody else. So you have one, two, three, four, five. So there's five possible pairings, and then four, three, two, one. You could add those all together. That'd be one way we could get this 5, 9, 10, 11, 12, 13, 14, 15 different pairs from this group. So another way to look at the two together is before, like if order was important, if we listed all of the A's and then all of the B's with, right, so there would be five here, and that would end up being five, 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 or what would be six different people times five. That would be the permutation of six people, and you're choosing two of them, right? Well, that's 30, but when you have two things, there are two ways to arrange them, right? Which is the number of ways you can put two things in order is 2 times 1, which is 2. There's two ways to arrange two things. So if you take out all those different repetitious, all those redundant pairs, you'd end up with 15. So same thing. All right. So moving on. Now there is a sheet on your Canvas of notes. Hopefully you've printed that out or looking at that as we go along. All right. So same group of people, how many ways can 3 of them be selected to plan a fundraiser? Well, getting into 3 gets to be a little bit harder of a list, but if we stick with alphabetical, it's not so bad. So A, B, C would be your first, and then just only change the last letter. So it'd be A, B, D, A, B, E, A, B, F. Well, we run out of people here, so change the second letter and keep it alphabetical. So B would be C, then that would have to be D to be alphabetical. So A, C, E, A, C, F. And then you would get to A, D would go next. So E would be alphabetical. And then A, D, F. And of course, A, E would be next, and F. So those are all the 3-person groups that include Adam in them, right? So then we're not going to include Adam, so you'd start with B and alphabetical. B, C, D, B, C, E, B, C, F. And then F was the last one, so B, D would be the next one in the alphabet. E, B, D, oh, F. That ends that, so B, E, F. So there are there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 groups that include Adam. Well, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 groups that contain B. Was that Betty? But 4 of them we already counted, right? So there's only 6 new groups. So this is 10. This is 6 more. And when we get down to C, Carl, C, D, E, have to have C, D, F, and then C, E, F. We ran out, and now we only have 3. So we've already had Carl. Oh, scratch my eye. Hold up. So Carl was already in 1, 2, 3, 4, 5, 6, 7. So we already had Carl in 7, so there are only 3 more that he wasn't in. And then finally, starting with D, we would just have D, E, F, and nowhere else to go because D was already in 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's the 10th group. So each one of them is going to be in 10 possible groups, but there's going to be a lot of overlap, so you don't want to count those every time. So that's 1. So this would be 10, 6, 3, 1. Add those up, 16, 17, 18, 19. There are 20 possible groups that we can make with 3 of them. Just as a side note, these are called triangular numbers because these are the numbers that you need to make a triangle, like 10 bowling pins. 1, and then with 3 dots, you can make another triangle. Then if I want to make another triangle, I need 1, 2, 3 more dots, and that's 6 total. And then like the bowling pins, 2, 3, 4, and then that's 10 total. So those are triangular numbers. The next one I'd have to add 5 more and get a 15 total dots for the next one. But that just happened. So with this 3 group 20, but let's look at the way we did it with the multiplying, right? So if we have 6 people and we are going to permutate 3 of them, we would do 6, 5, 4. Bring this up a little bit. Is this going to work for me? Come on, work. Nope. Oh, yeah, it worked a little. Oh, no. Now we've gone and done it. Okay, let that catch up. This Promethean board software and the there we go. Moved up a little bit. All right. Oh, I probably did too much. Uh-oh. Moved off the page. Okay. All right, back to what we are saying. So if I had 6 people and I want to permutate, put 3 of them in order, that would just be 6, 5, 4. But since order doesn't matter, you're just grouping them, you want to divide out all those repetitions. All the different ways you can put 3 people in order would be 3 times 2 times 1. Well, you could multiply first or you could reduce, right? Because 3 times 2, that would reduce out that 6. 5 times 4 is 20. So like we said, there are 20 ways to do this. So this is what's called a combination. So we can write this as 6C3, or that's the same as doing C 6, comma 3. And to do that, we would take the first 3 numbers, just like before. So it'd be 6, 5, 4. But now for a combination, yeah, not answering that. So 3, if you can hear that ringing. And then divide by starting with 3, 2, 1. Like I said, 20. All right. So I'm going to stop the video here and then move on to part 2, which we'll talk about writing the formula for a permutation. We're going to do 6 people, choose 4 of them this time. And I'm not going to list that out, but just look at the formulas. All right, go on to part 2.